Welcome back to the chapter on arithmetic progressions, and we're still on the topic of problem solving. So previously we found how to determine whether a sequence is an arithmetic progression. We found how to find the common difference d, the nth term tn, the number of terms in an AP n. In this section, we are going to learn how to find the sum of the first n terms of an arithmetic progression, which we denote by Sn, S suffix n. So let's proceed. Now these are the terms of our arithmetic progression. Each blue line is one term of our arithmetic progression. And in this arithmetic progression, which I've shown in the form of these blue bars, has n number of terms. So in this section, we will learn how to find the sum of all these n number of terms of our arithmetic progression. So if you remember the naming system, the first naming system that we learned, we call the first term A, then the second term a plus d. We are going to use this system here. So the next term will be a plus 2d, a plus 3d, and so on up to the second last term will be a plus n minus 2d, and the last term will be a plus n minus 1d. So this is our arithmetic progression, and what we want to find is the sum of all these n terms. Okay. So how do we go about doing this? Now what we do is, the first step, we take this same arithmetic progression, except that now we arrange it in reverse order. Okay, we make the order ulta. So the we'll use these same terms, but now we'll go from right to left. So I'm going to put these terms on the top of the terms that I've already put on the screen. So the first term will be a, but this time from the right. So we go a plus d, a plus 2d, and so on, and all the way. The last term will be at the very left, that is a plus n minus 1 into d. So what we are interested in is this sum, right? We want the sum of all these terms, and that we denote by Sn. We've already discussed this. Now, if you look at the new arithmetic progression that I've listed on top in reverse order, even though it is in reverse order, all the terms of that arithmetic progression are also the same. So all these terms will also have the same sum, which is Sn. Okay. So what have we achieved by doing this, by listing this arithmetic progression in reverse order again? What we have achieved is, if you look at these two terms, okay, for example, on the very left you have the bottom term is a and the top term is a plus n minus 1 into d. So if we, these corresponding terms, if we add them all together, what we get is, now we have each new term that we've got by adding the previous two terms in each pair. Each new term is the same. It has the same value. If you can see, all the bars have the same height now. So the idea is, now our calculation is very simple, because all we have to do is find the value of one of these terms and then just multiply it by n, because we know that we have n number of terms, right? And how do we find the value of one of these terms? We simply add. So if you look at the leftmost bar, the bar on the very left, it is the sum of the first term a and the last term a plus n minus 1 into d. So when we add it, we will get 2a plus n minus 1 into d. So what we get is, each of these blue bars is now 2a plus n minus 1 into d. And like I said, to find the sum of all these terms, all we have to do is multiply this by n, because we have n terms. So we multiply the value of one term by n. So the sum of all these terms will be n multiplied by 2a plus n minus 1 into d. I hope that is clear so far. But is this what we want? Is this what we were interested in? No. We were interested in the sum of all the terms in our arithmetic progression, and this is actually the sum of all the terms in our arithmetic progression plus the sum of all the terms in the second arithmetic progression that we put in reverse order. So this is actually twice the sum of our original arithmetic progression. So this is 2Sn. So 2Sn is equal to n into 2a plus n minus 1 into d. It's very easy to make a mistake at this point, especially in your examination, when some students will think that this is it, this is the formula for the sum of n terms of an AP. It is not. It is twice the sum. So to find the sum that we were interested in, the sum of the first n terms of the AP, you have to take this 2 to the right hand side. So what you get is Sn is equal to n by 2 into 2a plus n minus 1 into d. And this is the formula that we are interested in. Okay. Now, in your examination, you might be asked to derive this formula. Okay, they might ask you to derive the formula to find the sum of the first n terms of an arithmetic progression. Now, obviously, in your exam, you cannot sit around doing all these, drawing these bars and showing it graphically. So I'm going to show you how to derive this formula algebraically. So let's move forward with that. So to find the sum of the first n terms of an AP, the first thing is we list the terms of an AP according to our original naming system. So we say let the arithmetic progression be a plus d, a plus 2d, and so on all the way up to the last or nth term, which is a plus n minus 1 into d. And next we define all the terms that we have listed and that we are going to find. So we say where a is the first term, d is the common difference, and then finally the thing we need to find, we say let Sn be the sum of the first n terms. So we've listed all the terms of our AP, we've defined what is A, what is D, and what is Sn. So now since Sn is the sum of the first n terms, so we say therefore Sn equals a plus d plus a plus 2d and so on all the way up to a plus n minus 1 into d. And if you remember what we did previously, we listed the same AP but in reverse order with the same sum of all the terms. So we say therefore Sn is equal to a plus n minus 1 into d plus a plus n minus 2 into d and so on all the way up to a, the first term. So the second progression we have listed in reverse order. Okay. So if you remember the next step, we added both all the corresponding pairs of terms together. So the first term of our original arithmetic progression and the first term of our new arithmetic progression, the second term of the original and the second term of the new. So even in this case, we do the same thing, and on the left hand side, we get Sn plus Sn, which is 2Sn. So 2Sn is equal to 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus 2a plus n minus 1 into d n times, because we had n number of terms, so we keep adding this 2a plus n minus 1 into d n times. And if you remember how we got the 2a plus n minus 1 into d, it was by adding the first and the last term, right? It was a plus n minus 1 into d gives you 2a plus n minus 1 into d. What's the next step? We know that adding 2a plus n minus 1 into d n times is the same as multiplying it by n. So we simply say therefore 2Sn is equal to n into 2a plus n minus 1 into d. And finally the last step, which you should not forget, is to take the 2 to the right hand side in the denominator. So therefore Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula that you will be using to solve most of the problems in this section on finding the sum of the first n terms of an AP. But before we finish, I just want to draw your attention to one little point. That is, if you look at this term 2a plus n minus 1 into d, like I said, we get this by adding the first and the last terms. So another way to write this formula would be Sn is equal to n by 2 into a plus l, the first term plus the last term. So this formula also you might have to use in your examination. Now the question arises, how would you know which formula to use when, right? And the simple answer is, it depends on what you're given in the question. So if you're given a, n and d, okay, the first term, the number of terms and the common difference, then you use the first formula. If you're given a, n and l, then you use the second formula. So it all depends on what you're given in the question. So that ends our section on the derivation of the formula for the first n terms of an AP sum. Now let's move on and do some problems based on this formula. So our first problem is to find the sum of the first 10 natural numbers. Okay? So first let's write down what is given in mathematical terms. So since you know that it's the first 10 natural numbers, the first term a will equal to 1 because that is the first natural number. The common difference d is also equal to 1. Why? Because the difference between any two consecutive natural numbers is 1. And finally, they've given you that there are 10 natural numbers that they want you to find the sum of. So what will n equal to? N is equal to 10. So we know a, n and d, and we are asked to find out the sum. So we want to know what is s10, right? S10 is equal to how much? So which formula do you think we're going to use? Since we're given a, n and d, we will use the first formula. So let's take the formula. Sn is equal to n by 2 into 2a plus n minus 1 into d. Now all that remains is to plug in the values that we have. So we get S10 is equal to 10 by 2 into 2 into 1 plus 10 minus 1 into 1. So when you solve all this, you get S10 is equal to 55. So your final answer will be, therefore, the sum of the first 10 natural numbers is 55. Now let's move on and do another problem based on this formula. So here we are asked to find the sum of the first n natural numbers. Mind you, in the previous problem we had to find the sum of the first 10 natural numbers, but here it's the first n natural numbers. So again, let's list what is given to us. Since it's natural numbers, we know the first term will be 1. Again, the common difference will be also 1. But this time we don't know the value of n, so we just write n equals n, right? And what do we have to find? Sn, the sum of the first n natural numbers. So since we are given a, d and n, we are not really given the value, but we are told to find the sum of the first n natural numbers. So we'll still be using our first formula. So let's write it down. It's Sn is equal to n by 2 into 2a plus n minus 1 into d. So now we start plugging in the values that we have, meaning the values for a and d, both of which are 1. So we get, therefore, Sn is equal to n by 2 into 2 into 1 plus n minus 1 into 1. So simplifying this, we get Sn is equal to n by 2 into 2 plus n minus 1. And 2 minus 1 is 1. So inside the brackets, it will become n plus 1. So our final simplification will be Sn is equal to n by 2 into n plus 1. Now, since they haven't told us the value of n, it is perfectly fine to leave your final answer in terms of n. You don't have to go any further. You can just leave the n in the formula as it is. So our final answer will be the sum of the first n natural numbers is given by Sn is equal to n by 2 into n plus 1. No need to go any further. You can leave the n as it is. And with this, we come to the end of our section on finding the sum of the first n terms of an AP. So thanks for watching, and I'll see you in the next video.